All right, so we're gonna get started. It's 10:30, some folks are still straggling in, but I'll do our quick intro and let everybody know what's going on. So, welcome everybody. This is a webinar that has typically been reserved for the Green Star Business Network participants. The Green Star Business Network is a network of businesses that have self-selected to be leaders in sustainability in their given industries. But because this is such an exciting and awesome topic, we are opening it up to eco leaders today as well. So there will be a good number of more participants. My name is Kate Christian. I'm the Corporate Sustainability Coordinator at EcoCycle, and I run the Green Star Business Network. Today, we have Dan Matsch, the Director of Composting at EcoCycle, and Rosie Briggs, who has a heck of a title. It's the Community Campaigns and Eco Leaders Network Manager. So these guys are really doing some great work on carbon farming and carbon sequestration. Before I turn it over to them, just a couple quick logistics. If you have any questions, please feel free to add them at the Q&A section down at the bottom or in the chat. I'll be taking a look. We're not going to be asking them to Rosie and Dan until after they've given their full presentation. Most of your questions are probably going to be answered during the presentation itself. If you have any connectivity issues or anything like that, or any technical issues that I can help you out with, shoot them over to me in the chat function. We are all working from home, so if there's any connectivity issues on our end, apologies. We'll be able to take care of them quickly, but we just appreciate your patience on that. So, Dan, Rosie, take it away.
Hi, everybody. Let me do the little screen share dance here. Okay, is that visible? Is that coming up?
Perfect.
Good, okay. Thank you, Kate. I'm Dan Matsch, Compost Department Director, as Kate mentioned. And today I'm going to talk about carbon farming and carbon sequestration along with Rosie. And apologies, chances are real good I'll have to turn off my video at some point to keep my connectivity. So apologies in advance. So I want to talk about something we're really excited about at EcoCycle, growing and hopeful movement, both locally and globally, that's connecting compost to climate change solutions. So first of all, I'm going to talk about, make sure I don't confuse you with terms. So when I say organic waste, I'm talking about food waste, yard waste, soil paper waste, stuff that we send to compost facilities, not waste from organic farms. So here's what nature does on its own. There is no organic waste in nature. As you know, everything dies, falls to the soil, and eventually adds to that soil. So in the last couple hundred years, we have altered that natural circular cycle and replaced it with this, the linear cycle, where we go over a short period from resource extraction to the landfill, including putting our organic waste in the landfill and thus not replenishing our soils anymore. And we're putting that stuff in the landfill, which you probably have heard if you've ever tuned into EcoCycle before, that not only is it a substantial portion of our waste stream, it's around 40% of our waste stream. It also is, when it is landfilled, it is a major source of methane, which is a very powerful short-term greenhouse gas. So carbon sequestration, what is that? it's really just getting back to that diagram that I had up just a minute ago, returning to a circular system for organic waste, and using the plant's natural ability to build soil, and just augmenting that with using compost and other means of building soil. So what you're looking at here is plants, as plants grow, photosynthesis itself sequesters atmospheric carbon in the soil. So that's the purple arrow that you're seeing. That is the action of photosynthesis itself sequesters carbon. Photosynthesis means that plants are creating a sugar, and they are putting that sugar down into the roots, and they exchange that sugar with soil microbes in a symbiotic relationship in exchange for plant nutrients. So that sugar is carbon. And when there is enough sugar, more than is necessary to support the plants in that soil, that extra sugar is sequestered long term as carbon. Then we are proposing to going back to also adding carbon through compost, and biochar is another organic waste that can sequester carbon. So by directly applying compost or biochar to the soil, just by the fact that compost and biochar are themselves significant amounts of carbon, they're both around, well, compost is around 50% carbon, biochar is almost pure carbon, and that. So that is adding to long-term carbon sequestration as well. Then the red arrow is there is some carbon that's lost within this cycle, where back up into the atmosphere. So there's a constant cycle, but then there's also excess stored in the soil long-term. That's carbon sequestration, and that's what we're trying to do. And it turns out that by applying compost and other organic waste materials to soil, we're going to talk about some research that implies that this is probably our best tool that we are aware of to fix the climate problem that we're in, and that we know that we can no longer we can't fix change just by conserving, just by changing the energy sources that we use. We have to actually draw down carbon from the atmosphere. I think a lot of us know that by now. And this is the best tool that we know of to do it. You know, there's crazy engineering schemes out there, like putting a bunch of mirrors in space, or you know, messing around with the ocean's pH. How about just building soil? Because it turns out that not only does applying organic material sequester carbon, it does build soil. As I mentioned, you know, we've all heard, you know, our whole lives about topsoil loss. That's why we have topsoil loss, is we have circumvented that natural cycle. And it turns out that there's a third benefit, that when you build soil, you have more nutritious food that you grow in that soil. It's the fact that the produce that we grow today is much less nutritious than our grandparents' food. So this solves three problems at once. So how do we get there? Why do we have to talk about this? Why don't we just do it? You know, the problem is that actually farmers don't use compost. They can't afford to. So that's a real, you know, we have to immediately look at that. You know, the end goal here is is getting farmers, getting agriculture to use compost. So you can either quantify those benefits, or there are many associated benefits of applying compost. It can replace fertilizer regimes. It can feed beneficial soil microbes, as I mentioned. It actually stores water in the soil to the point where it resists evaporation, because water binds to soil molecules with compost, and actually evaporates less. Or, I mean, that's a piece of it, and that's actually really challenging to do, because it's very, so that's the first bullet here, quantify the benefits for farmers to say, hey, actually, compost is worth this much to you. It's worth this many dollars to you. That's really tricky to do, because there's so many variables in farming. If we can benefit them for the carbon that they sequester, that's kind of that's the holy grail. And we've looked at that in terms of, can we create a carbon market? On the energy side, that's a possibility, because when you put up a solar panel, you know exactly how much fossil fuel you're offsetting. You can see it on the meter. When you're farming, there are so many variables. You can apply compost to the same field, and you have a completely different result from year to year, depending on your weather, what you planted, all these things. So that's proven to be really tricky. So what do we do in the interim? So like I say, that's the holy grail. Back to our current reality, and a lot of this is economics. So here's our local reality. We have on the left, here's our cost to landfill organic waste. This is talking about Boulder. There's a tip fee at the landfill of approximately 20 bucks a ton. It costs about 10 bucks a ton to get it there. So total cost 30 bucks a ton to landfill. Meanwhile, over here on the compost side, currently, we're hauling to the middle of Weld County, so we're hauling 3 times as far. The tip fee is higher because there's more processing necessary than just throwing it in a hole. And actually, the haul is 2-part. First, we take it to a transfer station. We pay a cost there. Then there's the long distance haul. Total cost 85 bucks. So 30 bucks versus 85 bucks. It's tough to move forward when the economics are not in your favor in this way. And this is our infrastructure situation that we have now. The reality is that locally and for certainly across the United States and many other countries, the compost facilities that are there, the companies that run those facilities, their business plans were not typically, we're going to compost food waste. Their business plans were, like, for instance, for our composter, they're called A1 Organics. They are the only compost facility in the whole Front Range that's licensed to take food waste at the present time. And as I say, they are in the middle of Weld County. They're 52 miles away from the transfer station in Boulder. And their business plan originally was they managed Coors Brewery's organic waste. They obviously generate huge amounts of organic waste at Coors, both hops and grains and a lot of liquid waste. That's what their business plan was. So we came to them in 2004 and said, what about food waste? What about post-consumer food waste that's highly contaminated? And they're like, doesn't sound good. And that's the reality across the country, that this that we have to talk the existing composters into doing this in the first place, and their facilities were not designed to take food waste. Their facilities are typically out in the middle of nowhere, like A1 is, a great distance from urban centers because it's smelly. So if we were actually planning for composting food waste, it'd be more like this, I'd suggest, where like as with let's say solid waste from wastewater treatment plants, that every community has a wastewater treatment plant. And I'm not suggesting that compost facilities should be a utility like that, because I don't think that's a good model. But nonetheless, I think it's clear that if compost facilities are close to the point of generation, then those economics work. Or at least they're competitive with the landfill, is what I should say. So that takes a different type of compost facility. It needs to be smaller and needs to be able to. It needs to have really good environmental controls so that it doesn't smell, so it doesn't pollute the groundwater. And that's what we're working towards. It turns out, so going back to looking at agriculture, because agriculture, as I say, is the goal here. Currently, with industrial agriculture, there's actually 3 major sources of greenhouse gas emissions from land that have something to do with agriculture. So, as I mentioned, we have the greenhouse gases from coming from landfills that are taking food waste. There's a lot of greenhouse gases from manure management. So the middle picture is a confined animal feed operation. That's how industrial agriculture has evolved to turn livestock production or dairy production into force it into an industrial model. So we're growing animals in huge buildings, and we have lagoons like this for all our waste and meanwhile methane coming off of it. And then there's the soil management itself. The more you work the soil, the more carbon dioxide. Every time you work soil, you're releasing huge amounts of carbon dioxide into the atmosphere. So you hear about the terms like no-till. That's what that's about, is minimizing the amount of carbon dioxide that's by minimizing the tillage. So there's opportunities to solve a lot of significant emissions here. Okay, so now I'm going to talk about the research that is the inspiration for the work that we're doing today. So in about 2008, a rancher in Marin County, California, was frustrated that he was trying to improve a ranch that he had recently purchased, and he was frustrated that the methods that he was using were not working. So he actually ended up hiring funding some scientific research from UC Berkeley. He brought some scientists onto his ranch to give him advice on how can he improve the soil in his ranch. And they suggested, crazy, how about using compost? And let's measure what actually happens to that compost. Does it stay in the soil, or does a lot of it end up off-gassing back into the atmosphere anyway? So this top diagram is basically the carbon sequestration type of diagram that we've already looked at. Some photosynthesis is adding soil carbon, then some gets emitted. So this bottom left photo shows. Well, let's look at the bottom right. So here's the plot layout that they did for their original study showing, they did a compost plot, a control plot, they did a plow plot, then they did plow and compost. The left photo shows the cattle on that ranch are, they've spoken. They prefer the sites that have, they're naturally drawn to the sites that have compost in it because that grass is better. So really significant research in that for the first time, believe it or not, we quantified, scientists were able to quantify what happens to compost that's put in the soil. There's so little that we know about soil. It's really, we in agriculture, we look at it as a substrate that plants grow in, and you grow the plants by applying fertilizer. And we've totally ignored the soil. So, as simple as this research sounds, this is groundbreaking. So what are we doing locally? We're blessed in Boulder County to have a lot of open space. Everybody knows that. A lot of it is agricultural open space, as we've bought up agricultural properties around cities to both act as a buffer and to preserve the agriculture. So the dark green, actually the shades of green here are all agricultural properties in Boulder County, and I haven't looked at this in a while. So the dark green is county, the lighter green is conservation easements. So a lot of this, the point is that a lot of the county is actually is agricultural still, which is awesome. A lot of it is owned by the county and municipalities, which is an opportunity to for local governments to kind of encourage their tenant farmers to look at their agricultural practices. And you may know, if you've been in the county for a long time, that that commissioners have been trying to convert a lot of 20%. There was a goal of 20% organic practice on Boulder County land by 2020 this year. They're actually pretty close to that. It's that kind of incentive that we have the opportunity to do here. So what are we doing? So Boulder County is doing a Marin style pilot on 3 types of ag lands. They're doing a trial on cropland just south of Longmont. They're doing raised pasture land, and they're doing trial on rangeland, which means it's unirrigated land that may be grazed for a short period of time before the grass is eaten up. So they're doing basic Marin style trials. CSU Colorado State University is doing those trials for them. City of Boulder also doing trials. They're looking more at how can they partner with the existing organic farmers who tend to be very small. How can they play a part in this? City of Boulder owns almost as much agricultural open space as the county does. So this is very significant as well. Looking at really cutting edge regenerative agriculture techniques. Regenerative agriculture simply means rather than sustaining, sustaining doesn't work anymore in agriculture. We need to regenerate. We need to rebuild the soil. So that's what that term means. And then we have some citizen science projects going on. So one is engaging farmers. It's focused on farmers. There's a City of Boulder's golf course is involved. Major land managers are testing their soil annually. It's a 10-year study looking at changing their practices and testing their soil every year to see if they can improve their soil, build their soil, and sequester carbon. So that's actually initiated by an engaged citizen named Elizabeth Black, doing really wonderful work. And then there's our project, which we call the Community Carbon Farming Campaign, which is a 3-year project. It's a combination of science. It's looking at can we measure carbon sequestration on urban land. This is not farmland. This is engaging people in their backyards. This is engaging families in a little science project to see, set up little plots, just like on the, it's again following the Marin model. And is it possible to measure it in a whole bunch of little plots on urban land? And then of course there's a real significant outreach portion of that, because we want, if we're only engaged in the agriculture sector, we don't have time. Agriculture moves slowly. It changes slowly. Transitioning for a farmer is a really big deal. They invest a lot of money in their equipment. If you're suggesting a change that impacts their equipment, that's a really big deal for a farmer. And they're naturally, they're a conservative group. It's difficult to farm. If you didn't know that, and speaking as a former farmer, the profit margin is really tight. So risk aversion is paramount for farmer. So it's important that we non-farmers understand this opportunity and help to encourage farmers to do it. So that's what we're trying to do here. So this is again, these are our goals. So I've mostly mentioned this here. But a couple of the numbers 3 and 4 here, I have not mentioned. So our project is linked to a national database. It's really exciting. It's called Open Team, and it's basically a partnership between researchers and software developers to try to quantify carbon sequestration and the benefits of the soil. I mentioned, if we could quantify benefits of applying compost, then we could tell farmers, here's how much that's worth in money. So that's an attempt to cut through all those variables that farmers deal with, and actually, can you measure on a specific farm, even a specific field or a specific crop, what's the nutrient value, or what's the sequestration value that's happening there? And so it's really tricky, and it's really exciting to be involved in this cutting edge stuff. And honestly, we don't really know where we're going with this database. And mostly it's not mostly, but in addition to that, number 5, it's just a fun project that's we're hoping is a good family little science project to do. So the trial design that we're using here is, well, first of all, we have 250 participants right now. Here's the map on the right, shows the participants in the 3-year study that we're doing right now. We're in year 2 of 3. So we did so we call all those people, those 250 folks all have plots in their yards, in their grass, in turf. We also did a 1-year garden trial last year, looking at that nutrient density piece. Can we measure an increase in nutrient density of a crop that they all grew? They all grew kale, so the design is that we divided evenly 5 different treatments among the 250. So there's roughly 50 people who applied compost, roughly 50 people who applied inoculated biochar. If you happen to know, we make a compost tea called microbrew at EcoCycle, and we inoculated that we inoculate biochar with that. It's basically beneficial soil microbes that you are throwing onto the soil with biochar. And then three others I won't get into that that are just they are not organic waste products. They are they're agricultural products that have the potential to be used widespread, you know, on big farms globally. We've done it's focused on soil, baseline soil sample, and then we're at the end of the first year and at the end of the third year, we're doing we're pulling soil samples, sending it to a lab that's in this open team network, and we're doing just really basic soil test data gathering. So and I won't get into exactly what, you know, if you know what organic matter is, that's a key indicator. But what we're measuring is total carbon, which means sequestered carbon. You know, that's ultimately what we're trying to measure with that lab work. And then we're doing some, you know, kind of anecdotal plant growth studies as well. So here is a typical plot. This is actually my backyard. As is typical in Boulder County, most yards are very small. We just barely can squeeze this into our backyard. So it's two 10-foot by 10-foot plots. One is a test side, and one is which means we applied the treatment, and one's a control. And then we do the soil sampling is within the centers of each of those. So yeah, this is a repeat. These are the same. These are the treatments. And here is our volunteer team. Here's a representative of our volunteer team going out and soil sampling. So we had 250 participants. Then we had a core team of around 20 volunteers who are actually going around and trying to stick these probes in the soils around Boulder, which is pretty tricky in a lot of places. And here is our, so we have a web page. The link is down here on the left with our year one results. There's all kinds of information on that web page. Please check it out. But I'm just going to highlight here the central message of it. You know, so this is after 1 year. So you can look. This is cumulative. So you can look at the 5 different treatments, and actually some of them lost organic matter strangely over the first year, which is, you know, I think it's weather related. So these two these two data points are interrelated. I won't get into exactly what this means, other than to say right now, you know, it's too soon to say. You know, really, the carbon sequestration happens over a 10-year plus horizon. We're kind of squeezing things into 3 years here. So after 1 year, we're not outside of the standard deviation yet, except for compost. You see compost actually does increase significantly, and that's, like I say, that's because on the soil. So you should be able to measure that. And then what you can do here is, as a participant, you can put your own site ID, which is, so my name's Dan Matsch, and so the site ID is the first 3 letters of my first name and last name, and then you can check your own results. So you know, the idea is that you get some feedback about your own soil. So next steps. So this year, so we've done the first 2. Right here, we're right in the middle, and year 2, we're using an app this year. We're taking a break from the soil testing because it is a slow process to monitor the change. So this year we're using an app that's again part of this open team network that is measuring. It's simply, anybody can do it. You just download this app onto your phone, and it walks you through a survey of your own soil. And the point is to learn about your native soil that you have in your yard, learn about its potential, And then you have some reference, some framework for the larger study, because it turns out that if you have sandy soil, you're going to have different potential than if you have silty soil or clay soil. So it's good to know what kind of soil you have, and it's actually interesting to see your geologic soil. You know, what does the USDA say about your own soil? You know, what's the geology of your soil, and you can learn that from this app. So and then next year we're adding a few new things, but I know we'll skip over that for now because I want to talk about this year. So I'm going to turn it over to Rosie now to talk about the opportunity that we have now, that we're looking for 250 more people to participate in. So take it away, Rosie.
Okay, thanks, Dan. So I'm going to talk about our next step, which is the observational carbon farming portion of this campaign. So like we said, we had about 250 people last year that did this on their yards and gardens, and we're still working with them. Obviously, we're still in year 2, and it's been really, really great and really, really fun. A lot of people have been learning a lot of things about their soil and talking to each other about it and talking to our volunteers. And now we're opening it up to 250 more people to do essentially the same thing, but just a little bit almost less structured. And we're going to introduce the Land PKS app that Dan was mentioning. And that's something that we just introduced this year, like Dan just said. And it's been a really interesting addition to our project. So the objectives, Dan mentioned the objectives of the carbon farming, the community carbon farming campaign as a whole, and the objectives of the observational carbon farming portion of this project are: 1, to spread the concept of carbon farming. So a big part of it is, as Dan is saying, this solution is threefold. We're not only restoring our soils, we're drawing down carbon, but we're also returning nutrients to our food. And the more that we can kind of connect those 3 things and spread awareness and do outreach on it, the better chance we have of accomplishing those goals. So you can see that we have this little yard sign in this picture. And so, you know, the idea is to make a visual campaign. So if I'm walking down the street in Boulder, I can see, or anywhere, you know, I can see all these yard signs and I can notice that a bunch of people are doing this thing together, and then I'll look it up and learn more. And then number 2, engage in science and a climate solution. So a lot of us, most of what I do is outreach, and most of the people that I talk to are very concerned with the climate. And I think, you know, studies have shown that the majority of people are in the world very concerned about climate change and its repercussions, but it's so intangible to kind of participate in a solution that's where people kind of lose hope and become apathetic. So the more we can engage people in this science and in a tangible solution, even if we don't know too much about that solution yet, the better. I think it gives people hope, and it engages people, and it's kind of a doorway into more activism and advocacy. And then create a model for any town, anywhere. So that's our third goal that Dan already mentioned, is this exporting aspect of this project, is that we'd love to, a big part of what we do at EcoCycle in general is pretty much every time we do anything, we want to be able to package it up and export it to somebody else so that other communities can take part in this too. So we know that, you know, 250 yards on their 10 by 10 plots, you know, that's not the end of the carbon sequestration that we want to achieve. We want to be able to export this to anybody so that, you know, we can be, if we can draw down carbon in our yards, we want everybody to be able to do it. So we want to be able to work with anyone who participates in this project to make it exportable and make it accessible to anybody. So those are our objectives. And then to qualify for this observational portion of it, you need to have a lawn that has a space that's 20 by 10. So like Dan showed in his photo, we need a 10 by 10 plot and another 10 by 10 plot so you can have control and test, but it can be anywhere. So we do have some people in our carbon farming project from last year that are doing it on a neighbor's yard, or you know, have asked if they have like a little open space in their neighborhood, something like that. And it doesn't have to be in Boulder County for this one. So for community carbon farming from last year and the coming 2 years, we wanted it to be in somewhere in our area so that we can go deliver the amendments, we can come take the soil tests. We don't have to drive to Wyoming to do it. But for this one, since it's mostly you, doing it on your own lawn, and just following along with the content that we're providing. It can really be anywhere. So I just got an email actually yesterday from someone in Africa who is interested in participating. So that's just a really exciting thing. That's we're already working on achieving our exportation goal. And then being willing to commit to the program for at least one growing season. So growing season is just summer to fall. And then, like I said, a big part of this project is the Land PKS app, and you can download it wherever you get apps. So if you have an iPad or an iPhone or a smartphone, it doesn't have to be an iPhone, just some sort of thing that can download apps. That's what you need for this project. So we will go into much further detail. Right now we're doing our recruiting for this project, and then we'll do more in-depth trainings on what it will involve and what we're asking of you if you sign up for this project. But just vaguely, quickly, you'll choose a test plot. So like I said, you'll have a 10 by 10 plot for control and a 10 by 10 plot for test, which means that on one side, the control side, you won't apply anything. And on the test plot, you will apply your soil amendment. You can still mow your lawn. You can still water or not water. You can still have your kids run around. Your dog can pee on it. You don't have to like set aside this untouched plot or anything. You just have to decide where you're going to apply a treatment and where you're not going to apply a treatment. And then, so we are still working out the soil amendment piece. We've talked about compost, but we may talk about biochar as well, since we do have that. You'll use the Land PKS app to learn about your specific soil, and then you'll input the data. So we'll walk you through it. We'll have videos, we'll have webinars. It's this really fun, there's all these fun kind of pieces in the app where you take like a ball of your soil and you squish it around and you see if it makes a ribbon. You compare it to a sticky note to tell what color it is. There's all these really hands-on, engaging ways to learn about your own soil through this app. And again, like we will walk you through it and we'll all do it together. You'll put up the cute yard sign that I showed to show that you're part of the project, so that we can spread, we can accomplish that outreach and awareness portion of our goal list. And we have yard signs available at EcoCycle. And if you're not in the area at all, we'll have a printable version for you. We'll do an intro webinar and then a video series to walk you through next steps. So like I said, once we finish doing our recruiting piece, we're going to do a big webinar with everybody, and we're going to talk through it and talk through questions and get feedback. And then we'll have a little video series. We'll have little videos going through each portion. So like, okay, now you've applied your compost. This is what you do next. And we'll keep in touch with you as well. So you don't just have to rely on a video. You can keep in touch with us in real time as well. And you'll be doing it along 249 others. So we'll all learn together, and it'll be a fun community thing to do. And then you'll have the option to get your soil tested in a lab. So you don't have to actually get soil samples like we are doing with the larger carbon farming project, but we will provide resources for if you'd like to send your soil off and learn more. We'll essentially provide other options and opportunities to go further if that's what you're looking for. So it'll be kind of a sliding scale. Okay, and then how to sign up. So I have a link here. Kate will send it out, I believe, so we can put it in the chat box. It's here. And so we have a web page to sign up. We have a web page where you can learn more, or you can shoot me an email and I can get you started. And that's what I have on that.
And yeah, there's a couple more slides, but let's stop there. I want to allow some time for Q&A. So yeah, let's open that up. And Kate, should I maybe I'll keep this up for a few, or should I stop screen share now?
Go ahead and keep it up.
Okay.
So we do have a bunch of questions. I do want to take a quick second and just say, I know Boulder County, you already touched on it. We don't have a ton of land. Some of us I live in a condo. I have no backyard of my own, but this is a great opportunity to also engage your place of employment in sustainability initiatives. So there's a good chance that where you work, there is a plot of yard. If you could get your business to set aside that little bit of land for use for carbon sequestration. And this is a great employee engagement tool. It's a great way to start the conversation. If you guys need any help whatsoever in framing that, to present that to your employers, please let me know. Do not hesitate to reach out. And then for our GSBs, this is a great opportunity for you to also push out this webinar recording to your employees to get them involved. We're all spending a lot more time at home. So anything we can do to kind of enrich that time and, you know, pull together more of a community feel, I think that's gonna pay off big in the long run, as they say. So to get to some of the questions that we've got going, does it have to be lawn, or could it be a vegetable garden used for your plot?
We're just lawn, right, Rosie? I think you're more familiar with the new aspect than I am. So I assume we're talking about just lawn, right?
Yeah, that's the idea.
Perfect. And then, do participants have to provide their own compost and soil amendments for the plot?
Yeah, so we'll talk more about that, but we will provide resources for where to get stuff. I mean, we'll put it all together, but for example, at Ace Hardware, you can buy our local compost from A1 for like $7. Again, we'll talk more about the potential of something like inoculated biochar again for this project, but yes. And we also, if you're not in the area or you don't have commercial compost available, we were going to talk about the potential of using your own backyard compost to apply as well. Right, Dan?
That's right. Yeah.
Is there a cost associated with the soil testing that you talked about?
Yeah, so what I think we'll be recommending for this new piece is to use CSU's Soil Lab, which charges $35 per sample. So if you're doing a test and control, that would be 2 trials or 2 tests. That is actually considerably more comprehensive than the simple 3-point tests that we did with the lab in the Open Teams network. That lab in the Open Teams network is trying to come up with a really simple, really cheap test as part of this effort to make really widespread soil testing. We may actually, we can reach out to them actually, but what we're assuming right now is that we would be recommending CSU, but they have a lot more information about, you'll learn a lot more about your soil with the CSU test.
And just to clarify, to be part of the observational program, you don't have to get a soil test. So you don't have to send your stuff off. That's just like an extra credit thing if you want to learn more. And we'll learn a bunch about our soils just using that free Land PKS app that we're talking about.
How can somebody check if they've already signed up?
I can check. We haven't, so right after this webinar, this is kind of our like soft opener for this campaign soft launch. And so this is when I know that people have filled out, I know we have like 2 forms, one from last year and one from this year. And I will be reaching out to everybody who signed up on either of those to talk about next steps and invite you to the coming webinar and ask if you have questions. And if you're not sure, you can always just sign up a 3rd time. It doesn't really matter. I'll just send you one email anyway.
Well, this is a good question. If somebody has room for more than 2 plots, can they do more?
So I guess if you want to trial more than one treatment, more than one soil amendment, absolutely. And that we had a couple people with the 3-year trial that we're already doing who wanted to do all 5 treatments. We have a couple people who did 4. So yeah, that's up to you. Certainly, yeah, if you want to trial your own backyard compost against the A1 compost, that would be interesting. So yeah, it's up to you. You only need one control if all the plots are generally the same, just by casual observation. If there's no significant difference, just looking at the ground, the plants that are growing there now, or the turf that's growing there now, if it all looks about the same, it's all about the same exposure in terms of orientation and exposure to buildings and stuff. You can just get by with one control.
Garrett, you get extra credit points for that question. When does this program start? Is it for the next growing season?
We're looking to start this as soon as possible.
Yeah, and it's not as time sensitive as the project that that's in year 2 already, in which with that trial, because we are taking soil tests and we're contributing to this database, we are being we're trying to be scientists here. We're trying to we're taking the soil tests at the same point from year to year. We're applying the treatment at the same time from year to year. This is more just about observing the soil that you have. You're kind of establishing your own baseline now, and then as you enter data on the app, you can see for yourself things slowly changing. So that's the idea. It's really kind of your own timing. So at any you have this growing season that we're really we're only the 5th day of summer here. So yeah, anytime this summer is fine.
Then somebody asked if they can do a city pocket in their park or in their neighborhood. I don't know that we can give them the go-ahead to try it on city land, but that sounds like a great conversation for you to have with the folks that run your park or that piece of land that you have in mind. Correct me if I'm wrong. We have that that go-ahead.
Yeah, and I will say that just mention that if you're not fertilizing, if you're not responsible for the maintenance of the landscaping, there may be fertilizing going on and whatnot that you don't have any control over. With this aspect, it actually doesn't matter. It doesn't, with the more rigorous science that we're doing with the 3-year trial, we've been saying if you don't have control over it, then maybe it's not going to work, because if a pesticide is applied, that might kill a lot of your soil microbes. So we've been trying to avoid that. But with this trial, actually, if somebody fertilizes or applies pesticides, you actually can just note it. You open the app and you click on the date, and you can say, fertilizer applied today. And if you happen to know what it is, then that's extra cool. But this app allows a lot more flexibility. You're just whatever happens, you can document it in this app, and then when you step back over time, you can see, you can start to look for trends. And so that's, as I say, we don't really know where we're going with this. This all is part of this really exciting network, and we're all learning together. What data can be gathered from this app used in this way. So you'll go to the Land PKS website, and you can see that there are thousands of entries all over the world. This app was actually developed for use in Africa, trying to help people in countries that have little support. Here we have a agricultural extension system that you can get a lot of questions answered. That's not necessarily the case in a lot of the world. So this is the app was actually developed for folks who don't have that support. So a lot of it's in Africa. other places in the world that don't have that support, and as a result that it's very graphic. There's a minimal amount of language used there because they're not assuming that you know English, so you can actually change the language actually. So anyway, it's interesting to see how many participants there are all over the world. You can zero in on, what's this little point in Greece, what's that? What are they measuring there? And you can hone in on one site.
So what you're saying is it's good for us to travel while we're all like social distancing from home. Right?
That's right.
All right. So anybody have any extra questions, please, now's the time to go ahead and send them in at the Q&A button down at the bottom, as we're starting to wrap up. We have one other question clarifying, is the observational farming just using compost, or would they be doing other treatments as well? Can observational participants choose which treatment they test?
Yeah, I think the answer is yes. I think as Rosie mentioned, we'll suggest some resources, where to buy the A1 compost bagged, potentially where to buy biochar, where to buy inoculated biochar. But yeah, again, there's lots of flexibility. It's up to you. If you want to use your backyard compost, if you want to use, I don't know, an NPK fertilizer, then okay, that's your choice.
Mm-hmm. Yeah, I think compost is just the one that's kind of the most maybe universally accessible. So if we are doing it with people outside of the area, compost is probably the one that they're going to find.
Yeah, we're hoping that lots of people use compost.
Yeah,
because that's the key. The point is that we're making this connection between compost and climate change, and what can compost do to affect climate change, so to impact climate change. So it's good to have other stuff in there to compare, but the focus is compost for sure.
Great. So we haven't got any other questions, so I think we're going to wrap it up there. For folks who are part of the Green Star Business Network, next week we are going to be hearing from Brittany, also an employee from EcoCycle. She's going to be talking about microplastics 101. It's kicking us off into July for our plastic-free July. We're going to be focusing on microplastics specifically, and we'll be having a speaker from the USGS who did a study on Rocky Mountain National Park and the microplastics that are coming through in precipitation. There we go. So keep your eyes peeled for RSVPs on that. We're going to be sending out an email recapping everything you heard in this webinar, and as well as links to the recorded webinar on YouTube and all of these sign up links as well. Dan, Rosie, this was awesome. Thank you so much for your time. I'm sure you're gonna have a bunch of signups after this.
Thank you all.
Thanks, guys.
All right, have a good one, guys.